Let us talk about the line theorems. The real purpose, the objective in this tutorial is that for us to be able to identify algebraically whether two lines are parallel or perpendicular to each other without looking at or without making use of any graphical tools, right? So here is, for example, a graph that we have, and then we have drawn two lines. The line 1 is, let's say this is my line 1. It has an equation of y is equal to x plus 5. And then the second line is y is equal to x minus 5. Now, in this case, whether we had the equations or not, as long as we had these lines drawn graphically, we could tell very clearly that these two lines are parallel to each other, right? Because parallel lines don't intersect, and these two lines do not seem to be intersecting with each other, right? But how would you come to the same conclusion without looking at them graphically? Alright, so now let us go back to our algebra days and try to remember what is the equation of a line in its general form. A line can be defined as y is equal to mx plus b, where m is the slope and b is the y-intercept of that line, right? So using this, I can say that I can define two lines such that these two lines have different slope and different y-intercept, okay? So let's say that is y is equal to m1x plus b1, and then the second line is y is equal to m2x plus b2, okay? So let's make an assumption that states that these two lines are not parallel to each other, okay? So if that is the assumption, that means at some point these two lines must intersect with each other, right? That means at that point of intersection, their x and y coordinates must be equal, right? Let's use the y coordinate to be equal and substitute that y of line 1 must be equal to y of line 2, correct? In that case, you can make a very simple relation that m1x plus b1 must be equal to m2x plus b2, right? Or you can find from this equation that the value of x coordinate at the point of intersection must be equal to b2 minus b1 over m1 minus m2. So this is a combination of x and the y coordinate that we can find when these two lines are not parallel. That means at the point of intersection, these are going to be our coordinates. For these coordinates to be real, we must define that this rational number that is obtained by the ratio of the difference of the y-intercepts versus the difference of the slopes must be real number, right? What if that ratio is not a real number? Because you could obtain a situation that m1 minus m2 is equal to 0, right? If the slopes are equal, that means the difference is 0. As simple as that. But when the denominator of any rational number is 0, that means that rational number cannot be defined. That means at that point, we could further define two cases. When the slopes are equal to each other of two lines, we can say that these two lines are definitely parallel because they are on the same slope, right? But what if I have one more condition? I say that b2 is equal to b1 or b2 is not equal to b1, right? In that case, I can tell that when the slopes are equal and when the y-intercepts are equal, that means these two lines are identical to each other, right? That is our finding number 1. But if the slopes are same and the y-intercepts are different, that's when we say that the lines are parallel to each other. So this is a symbol of parallel lines, okay? And isn't that what we have already found here, that if you go back to our starting point that we said that y is equal to x plus 5 and y is equal to x minus 5, and these were these two lines that we drew here, correct? You notice that these two lines are parallel, but you also notice that the slope of both of these lines are also equal, but the y-intercepts are not equal. And that is exactly what we have obtained here, okay? With that, now let us look at one more condition of how do you determine that two lines will be perpendicular to each other, okay? So far, based on our discussion, we have defined that when you have two lines and if their slopes are equal and the y-intercepts are not equal, that leads to a condition that the two given lines are parallel to each other, right? That is what our finding was so far. The second condition we would like to state that for two lines, if we obtain a situation that slope of line 1 is equal to negative and inverse of slope of the second line, that will always lead to a condition that the lines are perpendicular to each other. Okay. Given these two conditions that we have learned, let us go take a look at some examples to compute whether two lines are parallel or perpendicular to each other without even graphically drawing them. Okay, so let's go take a look at our examples. Alright, so in this example, we have been given that there is a line y is equal to 5x plus 3. And then out of these given 5 options, we are supposed to find which one of them is either parallel or perpendicular to this given line, right? So the very first thing what we need to do is find out the slope and y-intercept of this given line. In this case, very easy to compute. The slope is 5 right here and the y-intercept is equal to 3 units, right? Now let's define the slope and the y-intercept of each one of those given lines. So I can say that the very first line, I can state y is equal to x over 5 plus 3 over 5. I'm simply dividing by 5 on both sides, right? In this case, I can say that my slope is equal to 1 over 5 and the y-intercept is 3 over 5, right? In the second case, you have y is equal to 3 minus 3x over 15. So that means you could simplify by stating that y is equal to 3 over 15 minus 3 over 15x, right? So the slope is negative 1 over 5 and the y-intercept is 1 over 5, right? In third case, we have 3y is equal to 15x plus 15, or divide both sides with 3, you will obtain that y is equal to 15x divided by 3 plus 15 divided by 3. In this case, the slope comes out to be 5 and y-intercept is also 5. Simple enough, right? And in this fourth one, we are given the equation in the standard form, so we can easily determine the slope to be 5 and the y-intercept to be negative 3. And finally, you have the last one, slope is 1 and the y-intercept is negative 3 over 5. Okay, so the first one we have to find that when two lines have the same slope and different y-intercept, that means those two lines will be parallel, correct? In this case, we are saying that slope is 5. Which line has the slope 5? It is line number 3 and line number 4, right? These two lines, right? They have identical slope and they have different y-intercept, right? They both are different compared to our given option. So in this case, we can conclude that the line number 3 and line number 4, they will be parallel to our given line. So let's put a parallel symbol here, all right? And now let us look for the lines which have slope which is equal to negative and inverse of 5. That means I'm looking for a slope which is negative 1 over 5. This is what I need for lines to be perpendicular to this given line, right? And that will be identified here only. So we will say that our line number 2, which has a slope of negative 1 over 5, will be perpendicular to our given line. So this line is perpendicular, the line number 2. Okay. This line, the line number 1, is neither parallel nor perpendicular. So that's what we can say. And so is line number 5. So this is how you determine, without the use of any graphical tools, whether two lines will be perpendicular or parallel or intersecting to each other. Okay. So let's take a pause here, and our objective was to identify one algebra rule that can tell us whether two lines will be parallel or perpendicular to each other.